Close. Acceptable use policy. All right, so EULA, end user license agreement, and the part where it says like end user, that means if you buy software, this EULA is I want to say, the document you get, or the one that, when you just say accept, you install a new software, then they ask you must accept this before you can go on. That is the EULA. So that is a document or contract that you sort of agree to by using other companies' software. And that's the one, if you pirate or you give or you copy the program to other people or stuff like that, that you can actually get sued because of this. So this is a contract between the user and the software company. While this one, acceptable use policy, is basically between a company and his employees. So yes, so acceptable use policy is between the company and his employees. So that would be, or it could even be, let's say at your school, if your school decides they're going to open up the Wi-Fi for all students as well, then that's the sort of contract that you guys will sign, like on your code of conduct, that says you will only use a school Wi-Fi for academic purposes, you won't play games on it or download movies. And companies, when people, they'll sign that when they start working for a company, to say that they won't use the company's computers for private use, and they won't go on Facebook while they're supposed to work and stuff like that. So that is the acceptable use policy. So it's sort of, it's acceptable use of the school or the company's resources by the employees type of policy. And as I said, EULA is between the client and the software company. And that's the one you sign when you use their software, or when you bought their software, or the license to use their software. That's those two. USB. What is that? You, oh, okay. Universal serial bus. Yeah. Universal serial bus. And yes, that is a connection port where you can connect your devices to your device, or your peripherals to your device. All right, so yes, USB. Say again. Oh, no problem. It's fine. Yeah, so USB, Universal Serial Bus, it's where we connect peripherals to our device. And what a USB also does, it actually supplies power as well. As you know, that we can charge our devices through that. So that's the difference between USB and some of the all the types of ports we had, where USB can also supply power. Then in software, in programming, we get our programming languages. We get compilers and translators. Who can remember what's the difference there between a compiler and a translator? Yes, tell me. Okay. And then translator? All right, so compiler? Yes. So what a compiler does, compiler would, it takes all of your code of the program that you programmed, and then it changes all of that into machine language for the computer to understand at one time, and then it gets processed from there. While a translator just takes line by line. So it will take one line, change it to machine code, try to run it. Then take the next line, and so forth. So as you can think, they can now, questions like this, it can be abbreviated. You'll see I focused a lot of on just topics here, because you need to at least know the thing, and then I can ask anything around it. Like with these two, sometimes they really like to ask, like, what is the advantage of the one over the other one? So with like a translator, because you go line by line, It means even if there's errors, you can still test the first part of the program. That's what's nice about a translator, because it will go line by line and it will work until it gets to the error. While with a compiler, if there's an error, it can't run at all. But the nice thing about a compiler is once there's no errors and it changes the whole program into machine code, then that program runs faster because it's all already compiled, how to say. It's all already machine code. With a translator, it takes one line and changes and runs, and then takes the next line, changes and runs, and take the next line. So it could be a little bit laggy, the translator. So it depends. Both has got their advantages and disadvantages. It just depends on what you need. Then, yeah, no problem. I am recording, so it's fine. All right. Our next one, when we go quality data. So how do you know that the data that you've got in your database is quality data? What do you think? There's like certain things we need to have, or uh, yeah. So it needs to be relevant data. It needs to be accurate, meaning no mistakes, and it should be complete. So not just half of the information. You want as much as you can correct information. It needs to be there's a word for like up to date as well. I remember now. But sort of the information shouldn't be old. It should be current information. And yes, yeah. So to if they ask how can you ensure quality data, and then like if it's like a two mark thing, you're looking at validation and verification. That's sort of the two things you can do to make sure. And then validation is like what you said now. With validation, you can use combo boxes to ensure that certain things you can use some if statements, you can use radio buttons, anything that you can do to limit the choice pool and to make it easier for the user to enter would help with getting quality data. And then verification is to afterwards just to check that the information is correct and complete and so forth. So somebody goes and physically checks the stuff. So yes, to ensure quality data, you can use verification and validation to get that. So yes. Oh, cool. No, no problem. So the enemy of quality data is GIGO. Sounds like GI Joe, but so what would this GIGO be? Yes. So an example of that would be if the person types in the wrong information, then our answer will be wrong. So that is like if I asked you for the average age and I need everybody to type in the ages. And now people just lie and they type in random ages, 1022 and 1500. And then my average is going to say, oh, the average is 800, which is completely wrong because the people just typed in rubbish. So if garbage is inputted into the program, our results will also be garbage. That's what GIGO means. Then I'm going to jump to hardware is our next section here. So when we're talking about the BIOS, we get a word BIOS, we get the word post, and we get the word CMOS. Um, what are those three? Can anybody remember any one of them and sort of explain how do they fit together and work together and what do they do? Perfect. Close. All right, so that is our BIOS. So BIOS is firmware. So it's a type of software that's loaded on a RAM chip. And what the BIOS does, it does a post. As soon as the computer is switched on, the BIOS loads, and then the first thing it does is a post, the power on self-test, where it checks all the critical components if they're working or not. Once post is done, then the BIOS goes and locates the operating system and loads the operating system. Until the operating system is loaded, then the operating system takes over. So the BIOS is firmware, it's software on a RAM chip, which is started up as soon as the computer is switched on. And the BIOS does a post and then looks for the operating system and loads the operating system. And then CMOS, anybody remember what's the CMOS stand for? So yes, CMOS goes with the BIOS. The BIOS's settings is stored on a CMOS chip. CMOS is a type of RAM chip that we keep, and all the settings, like if you've got multiple hard drives, which one should be loaded, where is the operating system, and stuff like that, all those settings is of the BIOS is stored in the CMOS chip. So the CMOS base keeps all the settings for the BIOS. So the CMOS is stored. So there's many ROM chips. The BIOS is stored on a ROM chip, and the CMOS is also CMOS is also a type of ROM chip. CMOS stands for complementary metal oxide substrate. So if you take all those abbreviations or whatever, you'll see complementary metal oxide substrate. So it's a type of RAM chip where the BIOS data is stored. But the BIOS is also stored on its own ROM chip. So by saying CMOS is just ROM is very general in that sense, because I mean there's so many ROM chips actually out there. Every device, even our TVs and washing machines and dishwashers and microwaves and fridges, all of them's got ROM chips on. And then the software that's stored on a ROM chip is called firmware. And specifically for the computer, the BIOS is one of the firmwares we run. And then his settings is just stored on the CMOS. So it's technically not wrong, but very, very vague in that, yeah, it depends on the question. You might get a mark or might not get a mark for that. Yeah, go for it. Yeah. And then, all right, our next one's plug and play. Yes. So firmware is just software that's loaded on a ROM chip. All right. Plug and play. Do any of you know what plug and play is? Yes. So the key thing here that you could say is I'd say the key word here is automatic detection. So with plug and play, as soon as you add a device to your computer, and then the computer would automatically detect that new device, then that is thanks to plug and play. So there is, I'm supposed to have drivers here somewhere. We might get to it then. Yes. So I'm just thinking. Okay. So there's no. So examples. Well, a lot of things like a memory stick. You know, if you plug it in, then suddenly it just works. That's thanks to plug and play. Your keyboard and mouse. If you plug it, add it to a computer, you'll see it. You wait a bit and then suddenly it works. That's thanks to plug and play. The computer doesn't need to be on for this though. So it could be like a graphics card. If you switch your computer off, you insert a new graphics card, you put the computer on, then suddenly you'll see the computer just tells you, hey, new hardware is found. There's a graphics card. Install the drivers. Oof. Install the drivers and then it will work. So that's all plug and play. Like as soon as you attach a new peripheral or component, the computer automatically detects that there's a new hardware device added and it starts looking for the drivers. Now, drivers are software that allows the operating system to communicate with any hardware device. So, any peripheral or any hardware component has got drivers. And now, plug and play just helps us to from yes. So, peripherals is like a keyboard and mouse. Any device you add onto your computer, we just call peripherals. And components is like inside the computer. That's like your CPU and your hard drive. And so everything inside the tower is components. Everything outside, like your keyboard and your mouse and screen and joystick and whatever else you want to add on, those are peripherals. So it's sort of the same thing. Now, so the key word there is all of them needs drivers. Drivers are software. It's sort of like a translator. It's software that allows our computer to talk with that hardware device. And what plug and play does, as soon as you add a new component, it automatically detects that new component and then it starts looking for the drivers for that component. And that's what plug and play does. So keyword plug and play is automatic detection. That's the main thing. And then you can start adding drivers and stuff like that as well. Okay, we're good. Yes. Yes, so there's a variety of ways. I can ask you just what is plug and play, or I can ask you, you added a new device, and then the computer just automatically tells you about it. What we call that technology, say plug and play. Um, yeah, that's basically the two ways. There's nothing else I can actually ask. It will be literally one of the either give you a scenario and you have to tell me it's plug and play, or do the reverse. Ask you to explain what plug and play is. Between 1 or 2 marks. If it's 1 mark, then you just say automatically detects new components. If it's like 2 marks, then you say automatically detects and then looks for the drivers. That would be the second mark. All right. Then I'm going to stick with hardware for now. So we'll come back to those ones. We get three types of printers. There's actually more as well, but these are the common ones that you need to know. If you've got inkjet laser 3D printer, um, who could tell me some differences between them, looking at like the type of ink they use and how they print? Yes. Okay. Yes. Yes. So just use nice words for it. A laser, that powder is called the toner. So a laser printer uses toner, which is a powder, and then a 3D printer uses plastic, which they call a filament. And then the inkjet sprays the ink on the paper. A laser uses magnetism and they call it the infuser. So it's just a roller that's very hot like an iron to melt that powder onto the page. And a 3D printer also uses a nozzle that actually melts that plastic and puts it on the right place. Alright, and that's all you need to know between the three of them. A fuser. Okay. Then the next two things we're going to look at. Firstly, the CPU itself gets placed into a ZIF socket or CPU socket. You can use either one of the two words. The ZIF socket is the, I want to say, more technical, nice word for it. The ZIF is for zero insertion force. Means when you want to add a CPU to your computer, zero insertion force. So do not force the thing in. You'll see it will just slip in nicely. If it doesn't slip in nicely, then it means your CPU is not made for that motherboard. Then you need to think of something else. So that's where the CPU goes on the motherboard. Then we also get PCIe or PCI Express slots where we can add expansion cards like our graphics card, sound card, and a NIC. What is a NIC? Okay, so NIC is for network interface card or network interface controller. So that's just basically the card that allows our computer or device to connect to a network. Sound card allows us to listen to or to have sound or to make speakers work on our device. And a graphics card is where our screen gets plugged into. Yes. So PCI is just the older version. PCIe, the E is for express. So it's just a faster version of the PCI slot. So they also look a bit different. But technically, if I'm going to ask you the difference, you just tell me PCIe is a lot faster and newer technology. PCI is older and slower. Okay. Then our next one, on our motherboard, we also use buses to connect components or point to point. What's the difference between these two types of communication on our motherboard? Maybe how do they look? What are they? Okay. So it's close. What I would want you to add there just is, so point to point is between two components dedicated. Generally, your point to point is like between RAM and CPU. So the two components that's supposed to talk very fast and should not be disturbed. So our two most important components in our computer, which is our RAM and our CPU, the one that does the processing and the place where it's stored. So those two, they will have a point to point connection, meaning only those two can communicate with each other on that channel, and then it's very fast communication. While a bus would be shared between multiple components. So that would be your keyboard and mouse and all our input devices and our hard drive, and all of them could use the same cabling to connect maybe to the RAM. And that's a bus. Generally, if you look on a motherboard, I don't know if any of you, if you Google a motherboard, you'll see there's like copper pathways, or there's like any circuit board. It's like a green board generally, and there's like lots of copper lines going everywhere. Those are buses or point to points. So it's just sort of cabling inside the circuit board that transmits data and power and all those things. They are generally buses, but you do get, if some of them are dedicated between two components, then it's called point to point. Okay. Yes. Yes. Yeah. Our next one. The difference between memory and storage. What do you say? What is the difference between memory and storage? Okay, so that's one thing. Memory is temporary, storage is permanent. What else? Speed wise? Memory is faster, storage is slower. If we look at size-wise, memory is smaller, storage is bigger. If we... Sorry, Apavan? Yes. No, so that goes hand in hand with volatile. If you say, so when we say memory is temporary, storage is permanent, it means when the power goes off, the information either stays or goes. So that is volatile as well. So memory is volatile, that's the nice word to use for it, while storage is non-volatile, meaning when the power goes off, it stays there. But like Pavan said correctly, just be careful. You can't say memory is volatile, memory is temporary, and memory, when the power goes off, the information is lost. All three of those things are volatile. That's why we use the word volatile. So then you'll only get one mark for those three things because it's the same thing. You're just putting into other words. So yes, saying memory is volatile and storage is non-volatile is a better phrasing. I like it much more than the temporary and permanent. And then if we look at cost, yeah, so that would also then be the same thing. So if you say short term or temporary or volatile or is lost when the power goes off, all of them is the same thing. But yes, for all of them, I would give you one mark, but I can't give you two for them. If you mention all four things, you'll still only get one mark because all of them refer to the same thing. So, uh, yeah, but you see, that's why I just mentioned look at speed, look at size. Next one is look at cost. If you look at cost between memory and storage, so the cost per gigabyte, memory is more expensive. So that's four nice reasons. They'll never ask for more than four. So memory is volatile, memory is smaller, faster, more expensive. And there's your four good reasons to remember. While storage is obviously the reverse of all of them. With storage also, we do have SSDs, which stands for solid state drives, and our HDD, hard disk drive. The difference between those two, yes, ele- yes, that's the right word. Electronics, the right word, because both of them is electric, but a solid state is electronic. And then, so solid state is also then faster than a hard disk drive. I wouldn't go size between these two. Some people like to say solid state smaller. That's not true necessarily. You can get a 10 terabyte solid state. It's just crazy expensive, but you get them. So I wouldn't go size. It's just solid state. Main thing is it's faster but more expensive. But then just remember with a solid state, it's still slower than memory because it's still storage. Yes, Papa. Yeah, yeah. Yes. Yeah, yeah. Yes. What do you mean with that? Yes. 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 What what does a head crash mean? Yeah, so HCD, it's on the inside there's a metal platter that spins, and then there's an arm that moves up and down. And on the tip of the arm is the head, and the head actually reads all the information. So that's like the reading part of the hard drive. So why they say head crash, if you bump and stuff, that head could get damaged by the spinning disc. And then if you damage that head, then you can't actually read the information. So it's not that necessarily that the information is lost. It might still be there. You just can't read it anymore because the head is damaged that actually does the reading off the platters. And that, So not no. So there could be a variety of reasons for that, though. I mean, if you copy a file and you sort of interrupt it in the middle, then that file could also be corrupt. Files can also get corrupted by viruses that does some damage. So it not necessarily. So it could happen that while you were copying it, something goes wrong on the hard drive itself that only copies like half the file, and that could cause a corrupt file. But it's not always because of that. It could be because of viruses as well, or just somebody copying something and removing power while it's in the middle or whatever. Okay. All right. Our next one, fragmentation. What does that mean? So it's close to that. Yeah, it's a little bit different. What I explained was while we're copying a file, while fragmentation happens, copying multiple files, and then just then putting them in different places. So now, because it's sort of when you're copying a file, it's let's say it's like a cluttered house. If you want to put a lot of things in, then suddenly you'll start just placing it wherever there's a gap in the house. You just put something down. So at the end, if you're looking for, let's say you disassembled your motorbike and you wanted to put everything in the house, but the house is full. So you put the one wheel in one room and the other wheel in the other room and the other bolts in the other room. And when you want to put it all back together, you have to go look all over the place for it. And that's sort of what happens to fragmentation. Whether adding and removing of files, your hard drive, the empty gaps tends to get scattered throughout the hard drive itself. So when you copy something, then it places it in those gaps. Let's say you install a new program. Instead of putting all the files for that program close to each other, it needs to scatter it throughout the whole hard drive because that's where the spaces are. And that's called fragmentation. So the solution to that is defrag. Defrag means defragmentation. And that's just when you ask the hard drive, hey, listen, please sort yourself out. And what it will do, it will actually go and group all the files together that should be together. So that when you read, it actually speeds up the computer. So running defrag could actually make your computer faster. And in some instances, it can give you more usable space as well. On the hard. Doesn't give you more space, but it does allow you to get some more usable space by running defrag. Yes. Yeah. So generally, I think there's quite a few different algorithms that it would run, but places it would look at it would I would think it looks at the folder structure firstly. If all the files in the same folder, remember if you see everything in the same folder, you think all of that is in the same place on the hard drive, and it's not. Wherever it can be stored, all scattered throughout the hard drive. But the folder you see, that icons, that is just sort of shortcuts. So it doesn't mean all those files are together. So no, so that's sort of each icon you see is actually just a reference to there's like a memory allocation. It will tell you this file is in memory slot 330 and the one right next to it is in memory slot 7033 million or whatever. So it could be like in completely different spots, but logically it's like shortcuts that's placed just together. So it looks fine to you, but it's not. So it would look at stuff like that, and it would also look at metadata, like where it's created. So it can see, listen, these files belong to the same program, and then it will try to group them together. But yes, so what you see in Windows Explorer and that's not actually where it's stored. It can literally still be stored anywhere. It's just you or Windows sort of grouping the links to where the files are at in the same place. But it's not where they're physically stored. Yeah. Yes. No, so it's software. So I want to quickly finish hardware and then I'm going to go through the software sections. Just because these things fit together. So so yes, you need to know them as well. Everything, even these top ones that I skipped, we need to know them, but I will come back to them. All right. Then the next one. Multitasking, multi-threading, multiprocessing, and hyper-threading. All right, so you need to know all four of them. You need to know the difference and how they belong to each other. So the first two is software based, so our operating system works with them. All right, so the first two is based on our operating system. Multitasking allows us to open multiple programs at the same time. Multi-threading is breaking one program up into smaller pieces and allowing all those pieces to run independently. Then these next two, they are hardware based. So that depends on your hardware. These two as operating system. Multiprocessing is if your CPU has got a multi-core, like a quad core, or if there's 5 cores or 6 cores or 7 cores, then it's multiprocessing. And what hyperthreading does, it actually went and said, let's create two registers for each CPU. So if there's a quad core CPU, that means you'll have 4 CPU cores. But having hyperthreading as well means each of those 4 cores would have 2 sets of registers. Now, a register is basically, it's also a type of memory where the information the CPU is currently busy with is stored. So a register is very small, it's very fast. I want to say it's faster than cache memory. So a register is like part of the CPU itself, and that's where what the CPU is currently busy stored. And what hyperthreading does, it gives you 2 sets of it. So that while the CPU is busy processing the one, the other one can load the next stuff. And then as soon as the CPU is done, it will go to the second register. And then the first one stuff that's processed will go out to the RAM where it should be. It will get the next stuff. And when the CPU is done with number 2, it will go back to number 1 where the next stuff is lined up. And then number 2 can go back and new stuff can be loaded. So that's what hyperthreading. Hyperthreading gives us 2 sets of registers. Multiprocessing gives us more than one CPU core. And then these two is our operating system. Multiple programs, and this is one program split into smaller pieces, and each of them running independently. Right. Those four. Yes. So your definition for hyperthreading would be each CPU core has got 2 registers to speed up processing. It's always two, yeah. 100%, yes. Okay, yes. So hyperthreading is each core has got 2 sets of registers. So in a quad core CPU, you'll have 8 registers being used. Yeah. To speed up processing. Okay. Then I think that's the end of hardware. Okay, let's go software. So operating system functions. Now this is grade 10 work that they really love, and it just really pops up every year, even up until grade 12. They love these questions. So operating system functions, there is 6 of them. You can remember any of them. Yes, 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 yes. Number 6 is manages application software. So that's a 6. Generally, they'll never ask you for 6, but they generally like asking you to mention like 1 or 2 of them. And they also sometimes they like the memory and the processing management a bit. I saw somewhere that they asked, so what does it mean that the operating system does process management? And your answer to that would just be basically the operating system can decide what should be processed next and what not. So the operating system will tell the CPU, listen, this program is minimized, so don't worry about it. It's not important. But this program is the current one that the user is busy running now and it's on his screen. So focus all your energy on that one. So the operating system basically tells the CPU which processes to spend more time on and which ones not so much. Our next one is open source software, proprietary software, freeware, shareware. So these are different ways that we can actually get our software. Proprietary software, that's the one you pay for. You pay for, it's copyrighted, you can't change anything. So our EULA applies to those ones where they say you can't copy it, you can't change it, you can't look at the code, everything is protected. While freeware is software that's free, so you don't have to pay for it, but it's also covered by EULA. So it's still copyrighted and you still can't look at the code. But because it's free, you can give it to other people, but you're not allowed to change anything on it. And then shareware is like that demo version, where you only get it for a month, or you only get it for a trial run, or only with limited features. So that one is also copyrighted and got a EULA. So all three of these ones are protected by copyright, and you can't actually look at the code or change anything with them. Only difference is this one you have to pay for. These two are free. This is the full program, that's just half of the program. Yeah. So advantages of proprietary software is generally because you paid for it, there's better support most of the time. So if something's not working, you can generally send them an email, they might come back to you, they'll help you with it. Sometimes some programs you can even phone a call center and they can help you with it. Generally there's a lot of updates coming out every now and again to help you to fix some errors. So, and that's proprietary software. Because you pay for it, that means there's actually people getting money for it and it's a company behind it. So then generally they try to support you as far as possible and to make sure the program is as good as possible. So that's the advantage of it. Yeah. Yes. Yeah, you can say that. And support. And then the other one, open source software, it's generally called OSS, but I saw lately they like calling it FOSS, FOSS, which is just for free open source software, which is just so stupid for me because open source software is free. So why you need to say that it's free, I really don't know. But some textbooks and some people like to say FOSS. But open source software is free, but it's not copyrighted. So you are allowed to look at the code, you are allowed to change the code as you want to make it suit your needs and do whatever you want to with it. So that's what open source software is. So all four of these ones are basically, it's distribution models as to how can you distribute the software. Either free, not copyrighted, or pay for and copyrighted, or free and copyrighted, or only partly but copyrighted. So that's the ideas behind them. Then let me see what else is software. Not so much those ones. All right, let's jump to our next section, which would be this is the ethical, social and ethical issues part. Yeah. And all right, so next one, a bug, a virus, and a Trojan. Um, so firstly, what is a bug, or do any of you know what's the difference between a bug and then these other ones? All right, so a bug, yes. Mm, not so much. Yeah. Yes. So the main thing is it's basically a programming error. So with a bug, it's not created to do damage. It's just when the person created the program, they might have forgotten about something or certain sequence of events, or it could be some hardware configuration between devices. So something like that could create a bug. A bug is just then, I want to say, it's sort of like a mistake on the programmer side that just makes the program not work correctly. But it's just an error. While a virus and a Trojan is part of malware. So the big umbrella is malware, and malware is just like all software that's created to do malicious stuff or wrong things. That's what malware, malicious software. And that includes our viruses and Trojans. So that is somebody that actually created software which does damage, and that's our virus. And our Trojan, remember the Trojan, the difference is a Trojan looks like a legitimate program, but in the background, it does damage. So that's what the Trojan does. And a virus is just software that attaches itself to another file that does damage. And then you get a worm that replicates himself. So they also come out. Now, you do need to know spyware and ransomware as well. I just mentioned these ones. You'll see like worm I also mentioned now, but it's just not here. But yes, you need to know all of them. Ransomware is especially um, in the news now lately. They love a lot of companies get attacked with ransomware attacks. So that is a common one that's out now. Um, do you know what does it mean when there's ransomware? What does that do? How does it work? Yes, so that's perfect. So the key thing there is the data is not actually stolen. The data is still on their software, on their computers, but it's encrypted, so they don't have access to it anymore. And only once they paid the ransom, then they sort of get the passcode to decrypt that software, and then they've got access to their things again. Um, then our digital divide, if you know what that is, that is the divide between the people that's got technology and can use it and the people that don't have it and can't use it. So it's not so wide lately. In the past, it was. That's what's in your textbook still. Because in the past, generally people in cities had access to internet and they could use technology. They all had phones and stuff. But then people in the outer smaller towns, they didn't have internet. They didn't have cell phones. Everybody, so they couldn't use those things. So that's a digital divide. But now lately that gap has closed considerably in that everybody generally now has got access to some kind of technology and internet. So that digital divide actually reduced a lot in the past few years. Yes, yes, that's good. Access and the ability to use it though. So age is also an aspect of it because some of the older grandparents and stuff they might not be so good with using technology. So that's also part of the digital divide. But nowadays, the amount of people that can't use it, because even older people have started to learn how to use technology. So that gap has definitely reduced in the past few years. Then the next one here, ergonomics, green computing, and netiquette. What are those three words? All right, so it's completely separate, but it's like key things that we sort of need to know. Ergonomics is basically how technology influences our health. So that's like our curved keyboard. You get ergonomic keyboards. That's better for your wrists, and you get an ergonomic mouse. That's better again for your wrist and your hand. And having good computer chairs so that your posture is good while sitting in front of a computer. Having your computer the right height. All of that is ergonomics so that the use of your computer and your device doesn't harm your health. And that's ergonomics. While green computing has to do with the environment. So everything we can do with our computers and stuff to not harm the environment. So save electricity, save power, recycle ink cartridges, reuse old components, green computing. Don't just throw your stuff on the dumps. There could be toxic chemicals in it. So by sending it to specific dump sites, your digital waste, e-waste, and so forth. So ergonomics with our health, green computing is the environment, and then netiquette has to do with etiquette on the net. So it's like good manners using the internet. So that's everything from you shouldn't swear at people, don't type everything in capital letters. When you're sending an email, put in a subject line. Don't say something to somebody on WhatsApp that you wouldn't say in real life. All sort of just good manners while communicating on the internet, I want to say. Then these ones are also part of our malware and our viruses and stuff, but these ones are underneath another umbrella called social engineering. So, social engineering, what hackers realized is it was too difficult for them to try and hack in to different people's computers and stuff. So now with social engineering, they're trying to convince you to give them information or to give them access to your device. And that's this part. So phishing is the key word with phishing is email. So you're receiving an email by somebody trying to convince you to give them some of your personal information or your banking details or your password and stuff. It's like emails you get say, oh, you've won the UK lottery. That's phishing. Spoofing is phishing's friend. So what spoofing does, it changes the from part in your email so that it looks like it's from somebody legitimate. So the hacker could be sending you the email, but then using spoofing software, he can make it look like it's from FNB or from ABSA. So he uses spoofing software so that when he sends you an email and you look at the from part, you'll see, hey, this is from ABSA. And then you suddenly believe. And it's just the software that made that happen. And then farming is creating fake links. So that's generally when you Google something or if you click a link to take you to a website and it takes you to the wrong website. That is farming. So farming has to do with links that takes you to fake websites. Phishing is an email trying to convince you. And then spoofing is phishing's friend by changing the from part in an email so that it looks like it's from somebody else or from a legitimate other person. Yes, yes, yes. Spooling has to do with your printer. So it's when you send, especially if it's, with networks, which we're going to, networks advantages and disadvantages. So an advantage of a network is that we can share hardware. So now in companies and like at schools and stuff, you've got one printer that a lot of people share. And that part, sharing of printers, when a lot of computers now suddenly say, I want to print something. that goes into a print spooling, where it's sort of like a queue for everything that needs to be printed. And then that spooler decides which task should be printed first and next and next. So that's the spooling part. Yeah, so spooling goes with printers and a printer queue, basically. Yeah. So bottleneck is um, when some device or some component of yours is just so slow that it reduces the speed of the whole system. So generally, like let's say in our computer, our RAM is very slow. The problem could be now that your CPU is fast, but it needs to get information from RAM. But your RAM is too small or too slow. And that reduces now the time. So your CPU basically waits the whole time because the RAM is so slow. And that's called bottlenecking. So all the information from the hard drive wants to be processed, but it needs to get through the RAM to get to the CPU. And the RAM is just too small and too slow. So if you can visualize that bottleneck, so it's all of that information in the bottle that needs to get out, and the output is to the CPU, but it needs to get through that small gap, which is our RAM. So that's the bottleneck. That's when a slower component reduces the speed of faster components. And that's called bottlenecking. All right, but you've got the idea now. All right. And then, so we've done that one. Let's look at this one. When we're looking at, so this is now sort of the next chapter, the practical part. Remember, I think we did discuss previously as well, three different errors we get. We get syntax errors, runtime errors, logic errors. So syntax errors is there's an error in the code. There's a red line, so the program doesn't even run at all. That's a syntax one. Runtime one means the program runs fine. But when you get to a certain stage, then if you click a certain button or something, then suddenly the program crashes. And that's a runtime error. And then a logic error, the program works fine. Everything goes, the output is just wrong. And that's a logical error. Um, okay. Modern div, I think that you guys know as well. Um, well, div divides it, but it only gives the whole number. It throws away the fraction, while mod only gives us the remainder. And then, yes, yes. Remember, there's a practical section, practical questions you get. Uh, yes. So you do need to know this. Um, and then I see my, yeah, yes, that as well. So your question should start, first question is short questions. Question like multiple choice or fit column A with column B. Question 2 is hardware. Question 3 is software. Question 4 is networking. Question 5 is generally databases. Question 6 is practical questions. So that's the syntax, runtime, logical errors, your div and mod. I could even ask you, I can give you a small piece of code, ask you what that does. I can even ask you to write me the algorithm for sorting an array. That I can also ask you. That's that part. And then the last question is generally the um, integrated scenario. And that's where all these phishing and farming and spoofing and malware and stuff comes in. Okay, I'll tell you just now. All right, I see my time. I'm going to need to go right now. But I've given you, so these things you must also know. So the ones that's white, I just didn't go through yet. So just to summarize the networking, our mediums, you get cabled and wireless. Cabled is like our fiber and UTP. Wireless is Wi-Fi and 3G. We get our different topologies. Generally, if I ask you, just go with star topology. That's a central one. That's where all the devices are connected to a central switch. You do need to know your VoIP, your protocols, and then those ones are databases. Yes. Yes. So go through that as well. You also need to know that. So you basically need to know everything, but these are